Hello guys, we are under lesson 4 in inequalities. Here we are going to see how to solve polynomial inequalities. Polynomial inequalities are solved in the same manner like quadratic inequalities. Consider this example. We are asked to solve this inequality and represent its solution on a number line and bring out the solution set. So here we are not going to divide both sides by x squared, because if we do so we are going to lose part of our solution. So what we will do is taking this way to have 4x cubed minus 6x squared less than 0. So with this, we see that 2x squared is common. If I factorize 2x squared here, I'll have 2x minus 3 less than 0. So from this step now, we reach our endpoint. So I'm going to say at the endpoint. The endpoints are the values of x which will make this 0. So the endpoints will have 2x squared equal to 0 or 2x minus 3 equal to 0, which give us x is equal to 0 or x is equal to 3 and 2. So on our number line, we are going to have, this is going to be, we have 0 and we have 3 and 2. So this one is a repeated root. So with this one, our bars are open. If I choose a number, here we have 1, 2, 3 regions. So I can choose a number. This is 3 and 2 is 1 point something. So if I take a number in the middle, which is 1, a number between 0 and this, putting 1 here, I'm going to have 2 times, this is 2 minus 3, which is negative 1. So I have negative 2 is less than 0, which is true. So it means this region satisfies. And if it satisfies, this and this will not satisfy. And our solution set will be such that x is such that 0 is less than x less than 3 on 2. For the second example, we are given the factors. So here we simply read the critical values that will make this 0. So the critical values, so I'm going to say the endpoints of critical values are such that our endpoints will be x is equal to, what makes this 0? Negative 1. X is equal to here 2. X is equal to negative 3. And x is equal to 4. So on our number line, this is our number line, we are going to have the smallest value, which is negative 3, followed by negative 1, followed by 2, then 4. And all our bars are open. So if you look at that, we have 1, 2, 3, 4, 5 regions. 5 regions to test. So I can start with a number here. A number here is 5. I'm going to put 5 all through. Putting 5 here. This is 6. 5 here, 3. 5 here, 8. 5 here gives 1. So if you multiply all this, our result is going to be positive. A positive number is greater than 0. So it means this region satisfies. If you take a number here, it is 3. If I put 3 in all these, I'm going to have here 4, 3 here 1, 3 here 6, 3 here negative 1. So all this gives a negative number. A negative number is not greater than 0, so it will not satisfy. So this one will satisfy, this will not, and this will satisfy. So with this, we are going to have this region and this region. So if this region satisfy, this will not, this will not, and this will satisfy. But for conveniency, it is always good to test the various regions. So our solution set will be such that here x is less than negative 3, union negative 1 is less than x less than 2, union x greater than 4. Thank you.